Okay, so what we're going to do today is we're going to talk about binary acids and oxyacids. The very first thing we need to do is discuss what an acid is. And no matter whether we use the Arrhenius definition or the Bronsted-Lowry definition, an acid is a proton donor. Meaning that it is going to give up an H plus. Acids are going to be compounds containing hydrogen that, for our purposes, are dissolved in water. Because of this, compounds are said to be aqueous. And therefore, have an AQ following the formula. Okay, so let me give a couple of examples of what I mean by all of this. One example that is a common example is hydrogen chloride. Hydrogen chloride, when added to water, becomes an acid. So HCl, when added to water, becomes an acid. And so it dissociates to form a hydrogen ion and a chloride ion. Now, most of the time, sometimes you're going to see an acid dissociation written in this format, but you can also find the same acid dissociation, because it is dissolved in water, to form hydronium, which is one of our polyatomic ions that we haven't used, and the associated anion. So again, an acid is going to be a proton donor, meaning that it is going to give up an H plus ion. For our purposes, these compounds are going to be dissolved in water, and therefore they are considered aqueous, which we represent as an AQ following the formula. Now, H plus and hydronium tend to be used interchangeably. Technically, the second reaction equation is more accurate because the acid is dissolved in water. And so we're illustrating that the acid is dissolved in water. So the second reaction is technically more accurate. However, I did want to illustrate both versions because you'll see both versions. Let's look at another example. When you take H2SO4, when added to water, becomes sulfuric acid. So H2SO4, when we add it to water, is now sulfuric acid. It is going to dissociate in water to form a hydronium ion and a hydrogen sulfate ion. Now, sulfuric acid is actually considered a binary acid, and I'll give you those definitions here in a moment. But basically, a binary acid is something that has more than one acidic hydrogen that can dissociate. So the definitions that I will say are monoprotic, which has only one hydrogen, diprotic, which has two acidic hydrogens, and triprotic, which would have three acidic hydrogens. Technically, yes, there are a couple of molecules that will have as many as 4 acidic hydrogens, but the most common ones that you're going to deal with in general chemistry for health sciences or college chemistry is going to be mono, di, and triprotic. Now, as illustrated with sulfuric acid, diprotic and triprotic acids dissociate stepwise. meaning one hydrogen at a time. Okay, so how do you recognize an acid? It depends upon the type of acid. For inorganic acids, which is the majority of types of acids you will deal with in this course and in College Chemistry 1 or General Chemistry for Health Sciences. The acidic hydrogen are listed first. In the formula. And I will end the formula with an AQ. I'm separating myself from active. Active doesn't necessarily list out the AQ, but I always will. Now, the other type of acid that you will get introduced to only a little bit is what's known as an organic acid. And an organic acid will have a carboxylic acid functional group. Meaning you're going to see a COOH with the acidic hydrogen being that hydrogen attached to the COO. And that was supposed to be an H. I don't know what it turned it into. Okay, so I just want to go back over the notes that I've given you about an acid at this point. And then what we're going to do is we're going to get into the formulas of acids and we're going to get into the names of acids. So the key points about an acid is that an acid is going to be a compound that's dissolved in water. When it's dissolved in water, it dissociates to form a proton, H+, and an anion. Now, because it dissociates in water, we tend to use that H+ and the hydronium interchangeably. If we have blah. Acids can be monoprotic, meaning they're going to give up one hydrogen. They can be diprotic, meaning they're going to give up two. Triprotic, meaning they're going to give up three. If they're diprotic or triprotic, they're going to dissociate in a stepwise fashion, meaning they're going to give up one hydrogen at a time. Now, the way you recognize an acid, if it's an inorganic acid, typically the hydrogen is listed first. The acidic hydrogens are listed first. And I try to go one step further in helping you recognize an acid by putting the AQ as part of its formula. For a organic acid, it's going to contain the carboxylic acid functional group, which means it's going to contain a COOH group, and that hydrogen attached to the COO is your acidic hydrogen. You're not going to see these organic acids to any great extent. We're mainly going to see the inorganic acids in this course. Okay. So let's talk about the formula. The number of hydrogens is equivalent to the charge on the anion. Here is where, once again, you have to know your anions of your elements. You have to know your polyatomic anions, because if you don't know your polyatomic anions, you're not going to get the number of hydrogens correct. So for example, if I were to say bromide, what is bromide? Bromine carries with it a -1 charge. So its acid is going to be HBr, because the number of hydrogens is equivalent to the charge. And then we will throw aqueous after it. If I ask you, what is the formula for nitrate? Nitrate has 3 oxygens, but it has a -1 charge. So the number of hydrogens to make that an acid is going to be equal to that charge. If I say phosphate, what is phosphate? Here is where the 3- comes in. Period, 3 down. Phosphate carries with it a 3- charge. So the number of hydrogens is going to be equivalent. If you don't know your anions, you're not going to know the number of hydrogens to put on the acid. Now, let's talk about name. Here, if you don't know the name of the ion, you're not going to know how to name the acid. If the suffix of the anion is IDE, then the acid is going to have the prefix hydro, followed by the root, and ic acid. If the suffix is ATE of the anion, then it is simply going to get an ic acid. And if the suffix is an ITE, then it is going to get the suffix us acid. So Cl minus is chloride. Because it has the ending IDE, the name of the acid is going to be hydro, chlor, to indicate chlorine, ic acid. If the anion is sulfide, then the acid, number one, would have two hydrogens and an aqueous. And number two would get the prefix hydro, sulfur, ic acid. So that is hydrosulfuric acid. All because the anion had the ending IDE. if our anion is, for example, I gave you NO3 minus earlier, that is nitrate. Because the ending is ATE, that means that it gets just the ic acid, and so HNO3 aqueous is referred to as nitric acid. If I were to give you the anion C2H3O2 minus, which is acetate, then the acid would have one hydrogen to match the charge. And because the ion ends in ATE, it's going to get the ic acid. And so this is acetic acid. If I have sulfite, now the ending is ITE. And because the ending is ITE, then number one, we would have two hydrogens because of the charge. Number two, this would be referred to as sulfurous acid. With the us acid due to the fact that it is an ITE. Okay, so let's look at how you're actually going to see this on an exam. Name those three. How I would do this is I would start by figuring out what the anion is. The anion in this case was Cn minus, which is cyanide. Because of the ending IDE, that means that it is going to be hydrocyanic acid. It'll be easiest to always start with what is the anion. The anion in this case is PO3 3 minus, which is what? It is phosphite. Because the ITE is going to tell us what we need to do to name the acid. We're going to need, this one is going to be phosphorus acid. Getting the us acid. The next one is SeO4 2 minus, which is what? Selenate. The ATE tells us what to do to it. So this becomes selenic acid. You'll probably have 5 formulas. You'll also have about 5 names. Whoops. Again, I break this down into the ions or into the information. That has ic acid. So what did it come from? It only has ic acid. So what was the ending it came from? It came from carbonate. So what is carbonate? CO3. Anybody remember the charge? 2 minus. So the formula for carbonic acid is going to be H2CO3 aqueous, with the number of hydrogens being equal to the charge. The next one, I noticed, has a hydro in front, followed by ic acid. So what does that mean for the anion? What is the anion? What does it end with? Ide. So this is iodide. And what is iodide? It's an anion of an element, I, and because it's in group 17, it's a -1 charge. Therefore, hydroiodic acid is HI aqueous. The next one I noticed ends in us acid. So what did it come from? What was the ending of the anion? It's ite, so nitrite, which has the formula NO2 minus. So nitrous acid is HNO2 aqueous. Questions? Yes. Because it is dissolved in water. What now? Mhm. Again, you're welcome to bring highlighters. It makes it easier sometimes to pull out the key pieces of information. Okay, so let me give you some to work. Yes. Oh, there's going to be a lot more material. It's going to be a lot of math. This is going to be the only naming that will be on this next test. And there will be 5 of each. But we're going to get into on Thursday, we're going to do scientific notation. We're going to get into measurements to the correct number of significant digits. On Tuesday of next week, we're going to get into significant figures. On Wednesday, we'll get into calculations with, Thursday, we'll get into calculations with significant figures. And then I believe the following Tuesday, which will be still on the exam, we'll get into molar masses. But that's just right off the top of my head. Okay, so the answer to the first one should have been chromic acid, and the reason for that is because the anion is CrO42-, which is chromate. And therefore, since it is chromate, the ATE tells us that it becomes ic acid. The next one in line, the anion that it came from is F-, which is simply fluoride. Because of the ending IDE, it gets the prefix hydro followed by ic acid. The last one came from the anion PO43-, which is phosphate. The ending ATE, telling us that it gets the ic acid. Okay, let's look at writing the formula for. So the first thing I did is I looked for ic acid, hydroic acid, and S acid. There were no hydros in here, so that means nothing came from an IDE anion. So the ic acid must have come from perchlorate. Perchlorate is ClO4 minus, so the acid is HClO4 aqueous. The S acid had to come from ITE, so it came from hypoiodite, which is IO minus, so the acid was HIO aqueous. And then for the last one, the ic acid had to come from ATE, so it came from borate. Borate is BO3 3 minus, and therefore the formula is H3BO3 aqueous. Questions? Like I said, that'll be at least 10, maybe 20 points of the next exam. With that, we are going to cut early instead of getting into numbers today. And we will start the mathematics on Thursday. If you came in late and would like your exam, please come up and grab it.